we've basically got two sections, which is where are we today and where are we going to be tomorrow. But there's a bit more information than that going on. It's a bit too wide even for Richard to come on. But to do a bit of an introduction to Richard first. So Richard is our CTO. And despite what it looks like on the screen, we are actually sitting next to each other here at UKBIC. He's been our CTO now for around about a year, but he has 20 years of battery experience in total. As you'll be able to tell very soon, he's from America, and indeed he's not long back to show North America as well. So he's met lots of people over there, saw lots of interesting things, hopefully a few of which he'll share with us today as well. So, Richard, I guess the first question that we're all asking ourselves is these charts show quite effectively that demand is skyrocketing, but demand where and demand for what?
Thanks, Jonathan. Yeah, demand is still very high. If we're talking about batteries in general, there's I think there's a temptation when we talk about battery demand, we talk about EVs first off, and the demand there remains strong, although that gets a lot more attention. Where we see lots of articles about slowing demand, and if you go, I've seen some of the talks by some of the people that track these things, and maybe demand isn't as strong as it was 2 years ago, where we were seeing 100% growth year over year. Maybe we're seeing a little bit 25% growth year over year, but adoption of EVs is still going up a lot. However, when people who are looking to invest in technologies like battery development are looking at growth and they see a slowdown in growth, it makes them think maybe there's a further slowdown, and so we start to see a little bit of a pullback in spending and development of technologies. But like I said, it's tempting to look at the EV space first, but we look further into the stationary storage space, drones, other mobilities, e-scooters, e-bikes, which I'm sure everyone sees in their communities quite often. That demand is still driving a lot of the market as well. So overall, the battery demand is still strong, and there's a lot of applications and a lot of need for it. China is still leading that. We see that there's still a lot going on in China. I think you see on the screen now that China has a lot of the market in terms of materials and in terms of processing and in terms of final application. China's done a very good job of owning a lot of the value chain, from raw materials and precursors all the way up through the processing steps and the machines that that we use in those processing steps, and into final applications.
And only this week we saw that China is now looking at export bans on certain technologies, such as machines that can make cells. And how do you think that's going to affect the situation that we see here? And then obviously the second graph shows the extent to which China is overproducing cells at the moment. So is this another step for them to increase their lead on other countries, or do you think there's something more behind it than that?
I mean, there's quite a grip that they have, and they've got some cards they can play. And China has been around a really long time and makes very strategic decisions, and is very good at it. And I don't think they do anything without thinking things through and in multiple scenarios. So we'll have to see how the new export control rules are going to play out. It seems wide-ranging. It looks like targeting LFP chemistries at a certain energy density, targeting NMC chemistries at a certain energy density, targeting machines that make some of the materials and some of the in-process steps that we talked about, and even some of the technologies. So people who are maybe relying on getting some knowledge, some of those things may be limited. I think I don't really know how it works. I think you have to petition the government to be able to get these things released. So it's not like it's banned, but it's controlled. And so it's a hurdle that I think that companies are going to be dealing with, but also not something that hasn't been talked about for a good bit of time now, that this could be a logical step in that. But I think it underscores that batteries are a pillar in terms of economies and the future economies for countries. And that's the way it is in the UK. That's the way it is in China. That's the way it is in the US. It's the way it is in Europe right now. And so, China has a large share of this market right now, controls a lot. And there will be, reactions to that reaction throughout the ecosystem, I think.
And I guess that brings us on to the next slide, which is the potential for batteries if you aren't China. Fundamentally speaking, so from a UK perspective, clearly we've got Agratas building their first gigafactory down in Somerset. We've got ASE up in Sunderland. There's there from New Automotive, which says there could be 300,000 jobs by 2030 in Europe. From a general point of view, how feasible is it that Europe, the UK can actually, I think, challenge China is probably going a bit too far, but become more independent in batteries, and is enough being done at the moment for that to be plausible at least?
Yeah, it's plausible. I think that there's a sometimes we think that this game is over, but there's if I look at, I was just rereading Steve Levine's book, The Powerhouse, not long ago, and it's kind of a history of where batteries came from, and it was written about 10-ish years ago. And at the end of that book, he leaves off where China's really just getting into this game. The book leaves off about 2015. That was only 10 years ago. And at that time, people from China are going to Argonne National Labs and saying, what is NMC? What is NMC chemistry? And now here we are 10 years later, and we're like, well, they're so far ahead, no one could ever catch up. So they had a great national strategy and played it, and it worked. And like I said, they've made that a pillar of their future technology, and the other economies in the world are doing that as well. I think that we really kind of have to look at it like that, as a strategic resource. I think we kind of need to educate people on this, and I think that the education is coming in places like UKBIC, but I think people are getting more involved in that.
And again, it nicely leads on to the next slide, actually, which is produced by our friends at UKRI, which is UK specific. So it's UK demand for batteries going forward by 2035. And basically the brown vehicles are how much AESC can produce, we think, by 2035, and the purple ones are how much Agratas can produce by 2035, as a best estimate, obviously. But that leaves an awful lot of grey there. That leaves an awful lot of demand that has to be filled. And obviously demand that has to be filled against certain backdrops, such as the EU battery passport, so on and so forth. So what do you think that future will look like for the UK? Let's throw Europe in as well by 2035.
Sure. So, we go back to, how's the UK, play in this? I talked about, where China was 10 years ago, and kind of we can infer where we are now. But how does the UK and the EU and to that extent North America start playing this game right now? And this in the UK, we have strong R&D base in universities. UKBIC is affiliated with the Faraday Institution that sits under the Battery Innovation Program. Faraday Institution is kind of like almost like our farm system for technology to do lower technical readiness level stuff, and hopefully deploy that and develop that through the rest of the ecosystem, ending up in UKBIC. We've had early investment in enabling infrastructure. UKBIC is part of that. We talk about technology, battery technology being a pillar of the economy and the technological strategy. We're sitting in a 200 million plus pound facility that the government in the UK said, batteries are really important. How do we as a government address that and build a facility that hosts other companies to come and develop their technologies. And we have a heritage in automotive engineering and advanced manufacturing in the area that we're sitting in the West Midlands, being in Coventry, in the kind of the heartland of UK automotive. But there are a lot of challenges with the UK, but there's limited gigafactory capacity compared to Europe and the US.
Not enough space, I guess, is one of it.
It's at the end of the day, it's an island, and it's not that big an island, and so there and to have the kind of Goldilocks type of place that you need to build a gigafactory, you need a lot of water, you need a lot of power, you need a lot of personnel there with the right skill set, and you need a customer base and be able to get a supply chain there. It's not like software where you just put a building anywhere and a bunch of computers and some desks and you can churn out a software company. You need the right type of place for a gigafactory. I'm looking at on the screen right now, the amount of demand that we're looking at for up through 2035, and what can be satisfied with projects that we have going on right now still leaves a lot. And I think what we need to understand is you need to be 2 years ahead to be competitive, because development times are so long. It's difficult to make batteries. It's difficult to make a lot of batteries. It's difficult to make a lot of batteries at scale. And we just talked about how it's difficult to even find the place. So even find the place to do it. So we have the demand available, and now it would be a matter of being able to satisfy that demand. And it's where we need to get governments to step in and work on the right technologies, that things that aren't being done in China.
And again, with this slide, it's kind of showing the amount of government support there. So you've got the Agritas Gigafactory, which obviously received a goodly slug of government money. The Modern Industrial Strategy was published in June. And obviously, batteries is a major plank of the key industries in there. Drive 35 from our colleagues at the Advanced Propulsion Centre over at Warwick. They're giving out key grants to some of the key players in the UK. Faraday Institution you already mentioned, which tends to do grants to PhD students on the research side rather than the development side. And the picture that you can see is actually someone from Wahoo Mobility from Ghana, who was here at the UKBIC, courtesy of an FCDO grant as well. So I guess the question with this is, there is support there. Is it enough support, and is it in the right sort of places to give us a chance to build a nascent UK battery sector that can actually punch above its weight?
Yeah, I think we talk a lot. This is a big question that comes up a lot, and so we've been talking about a lot. We've survived a lot in this game for a while by venture capital and things like that. But like I said, it's 2 years. You need to be planning 2 years ahead to be competitive, because development times are long, and a lot of private money and venture capitalist money it isn't really designed for those type of timelines and the type of buy-in that you need to build these things. I think someone was saying recently in a conference I was at that it's $2 billion US for every 10 gigawatt hours, and it's about 1,000 people for every 10 gigawatt hours. So that's a really large buy-in just to get going, because that doesn't even include all of the money you spent doing your R&D to get to that point, to get to that technical readiness level. So we've seen a model that works in China where the government was very much behind these things, and that's worked. And so since it's a long game, we're looking for those entities that can be in that long game, and that government support is an obvious place to look. The only negative side to that is that governments tend to be fickle. They tend to change hands of power, and
as we've seen in America quite starkly recently.
For example, and new administrations and new hands of power may have different ideas from what had been what had been done previously. And so, that can make it, that adds a little bit more of a hurdle in the West to be able to have that longevity, to be able to develop things. Because not only do you need to technologically be ahead, but it takes, you need to run a gigafactory at well over 90% efficiency, and it's going to probably take 3 years to get to 90% efficiency. That is a lot of scrap. So that is a lot of material that won't make it into a product that you're going to have to make up at some point with efficiency. So it's very difficult.
And on that forward-looking note, we will move on and ask Richard to get his crystal ball out and do a bit of future trend spotting for us. I guess we'll start off with chemistries and NMC, sodium ion, LFP. Are they the winners? Is that what we're going to see from going on? Is there more out there? Is one of those going to win? Is LFP the winner, for example? What's your view on the chemistry side of batteries?
I think that in terms of the chemistries available, every chemistry has an application. And so there's, like I said, anything that requires energy storage needs a battery of some sort. So I think anything on the screen from mid nickel to high nickel, NMC or NCA, sodium ion, lithium iron phosphate, they all have their applications. We've seen them. We've seen them out there. I think that we need to find tech that isn't being done in China and be able to capitalize on that. If the current generation of batteries and battery chemistry is settled, then you're asking me about the future, and the future changes daily, and we saw that just in the past few days, right, with export controls, more export controls coming on. So understanding where things need to go, I think is part customer driven. I think a few years ago we were very much about, we're talking about EVs, we're very, very much talking about range anxiety. So we worked very hard to get energy density up to have large ranges. Now we're talking about charge infrastructure and charging times. So the landscape of what the customer wants is changing, and we're kind of doing incremental bits on the chemistry side. Sodium ion has its place. I think we're seeing a lot in energy storage applications. It's an interesting thing against lithium iron phosphate as it gets away from the volatility of the lithium price. When lithium prices are very high, sodium ion gets a lot of attention. When lithium prices are very low, sodium ion doesn't get that much attention, but it does pretty well at low temperature. So there are applications for that where you could potentially use lithium iron phosphate, but maybe sodium ion is also a good solution for that.
And then obviously formats where, it's pretty much been a free for all. I guess I wouldn't say it's the Wild West out there, but there are so many formats, all of which seem to be doing about the same. There doesn't seem to be any one winner in there. So, what do you see as being more successful or more for the future, or do you think we're going to continue seeing all of these different formats for some time to come?
Yeah, and thinking about the chemistry a bit more too, we had some cathode chemistries on there, but on the anode side, there's still in terms of what we've just seen in the new export control rules, that China has over 90% of the graphite market, and just about every cell every cell you see on the screen and almost every cell you deal with has graphite in it. And so having the ability to lessen the reliance on China and lessen our reliance on graphite is probably going to be a big part of that. So we're looking at things like higher silicon types of chemistries that have higher energy density, have a lot of promise in terms of supply chain and the materials. Silicon is one of the most abundant materials in the world to be able to get, and if that can be deployed at large loadings into cells, then that's going to be a big hedge against China. I don't know I haven't seen a lot of silicon that I know of, 100% silicon anyway, that's coming out of there. And we think about form factors, formats that we have on the screen now. Again, like chemistry is every form factor. There's an application for it. I think what we're seeing a lot right now is a reversion to anything that's got a hard case, so cylindrical, so particularly 21700 and hard case prismatic cells. I think there's a few reasons for that. One, we've got pretty good at making 21700 cylindrical cells. They're pretty well known. We can make machines to make them at high efficiency, and that's a pretty well known form factor, and it can support lots of different chemistries. Prismatic cells, I think we're looking a lot at cell-to-cell propagation, and if there's a fire, and so hard case prismatic cells have good venting strategies and aren't breached as fast as a pouch cell. You give up a little bit more energy density, but I think that there are ways that they have been working on mitigating that in terms of pack engineering. I think I was attending a talk from a company called Element in the US. They're a cell testing company. They have, I think, 2,600 channels available to them. And they said their pouch cell volume year over year has basically fallen off. They're dealing mostly with cylindrical cells and hard case prismatic cells. Hard case prismatic also allows you to go from cell to pack, which we talk about a lot. So you can under-engineer the pack and take some weight out. You're adding weight because of the prismatic hard case, but that allows you to go directly cell to pack or cell to chassis, and that allows you to take some weight out of the engineered pack and module. So I think we're seeing some of that. There was a lot of news a few years ago about the larger diameter cylindrical cell, the 4680 that Tesla makes. It's in the Cybertruck. It's an interesting cell that a lot of really interesting things happening mechanically within the cell about how it's tabbed and how it conducts electricity. But it represents a nice balance between power, energy, and heat rejection. It will its heating profile will be a bit different than the 21700, which can make it an attractive option. You can get higher energy density in the cell because you have fewer can walls, I suppose, in your pack. But blade cells were pretty popular a couple years ago as well, and also in that area where you're trying to go from bearing a lot more load and going from cell to pack, cell to chassis type of thing.
Which leads us nicely on to what may or may not be the holy grail of the battery industry, which is solid state. So how do you view solid state? Is it everything and more? Is it actually coming? It's always been something that's been 5 years away. It's been consistently 5 years away for about a decade now. Is it coming? Is it going to take over? How good, bad, or indifferent is solid state?
Yeah, sometimes I think of solid state like fuel cells from the 70s, when fuel cells have been the next big thing for 50 years, and yet we're still not really using them, and they're still not really deployed. Solid state's been the next big thing for a long time. There are a lot of really smart people that are working really hard on solid state, and there's a lot of advances that are coming out on it. S&P Global thinks that solid state will lead to big charging time improvements by 2030. So they're looking at that very closely. It's very difficult I think at high volume. But again, every chemistry and every form factor has its applications. So I think maybe you'll see solid state in smaller applications first, whether that may be medical devices or watches or something like that, and maybe larger applications as we go forward. It's it's just very challenging. It can be reasonably unforgiving if you have any sort of defects or imperfections in it, and it's very difficult to make a zero defect process, and very difficult to make millions and millions of zero defect batteries.
And we've had a company called LeCain here, and they're looking at solid state technology, and they've pretty much done what you said, which is they've started off small with medical devices. And obviously it was a learning curve for us with Ilika as well. Do you think we're going to see more UK companies, for example, that are interested in the solid state technologies because of, I won't call it hype, because it might actually turn out to be true, but because of the sheer amount of interest that we've seen in them?
I think so, and the UK is also has a very strong R&D base. We mentioned Faraday Institution, mentioned all the universities that we have here. There's a lot of work that's being done with different groups that say, Imperial College London, Birmingham University, Sheffield. There's a lot that's going on at that level in the UK, and a lot that's being funded through the Battery Innovation Program in the UK and at Faraday Institution. So as we're talking about, where's the rest of the world going to play, you need to be 2 years ahead. You need to be excelling at something that China isn't already excelling at. These are the places that people are looking at. Okay,
which leads us on nicely to what needs to happen next from a UK perspective for us to get that competitiveness, to get that the battery ecosystem that we're stumbling towards at the moment. So, from your point of view, what are the important steps that need to be taken?
I mean, it's a really good summary of what we had here. A coordinated strategy is really important, and we're sitting inside, again, a facility that is part of a coordinated strategy in the UK. You talked about batteries being a technological strategic pillar for countries, and then following through on that. So, a coordinated strategy from, what we have in the UK through the Battery Innovation Program, through Faraday Institution, through Work Manufacturing Group down the street from us, and through UKBIC, and then into industry is important. The UK needs the supply chain depth, so localizing cathode, anode production, recycling, raw material strategies. There's a company we work pretty closely with in the UK called Altilium. They're doing recycled cathode active material. We've simply dropped that cathode active material into our own design here at UKBIC, and they've made cells, and they've presented results from those cells. The skills and training bit, thousands of jobs are going to be needed, from PhD engineers to operators. One of the things we do at UKBIC is we have a learning and development team that is there to upskill people in this area. It's not just for battery nerds like me. It's for people who are getting into this, because we see there's a lot of jobs that need to be created here, and but it's not just the direct jobs of people who are dealing with electrodes and cells. It's people who buy those materials, so supply chain people and buyers who have probably bought lots of stuff. Maybe at their last job they were buying paper, but now you're buying graphite, and you're buying cathode conductive additives. We'll teach you what all those things do and how a cell interplays with those things. So people who are in those kind of tertiary type of roles in battery companies, marketing and communications and the such, can start to understand these things that they're dealing with, and they seem really complicated, but we do a pretty good job at explaining them, so it can be very accessible, and people can get that. But there will be and they'll understand a lot of jobs to be created there, not just in the battery company itself, but beyond that, for all of the supply chain and people who move materials around and everything, that the knock-on effects of those things. And then finally into the gigafactory production. If that's all successful, we need to keep building those factories to supply the demand that we saw earlier on the previous slides.
Okay, super. In which case, if you've got any questions for Richard, if you want to pop them into the Q&A. So again, not the chat, the Q&A section. And we've got a couple of pre-prepared ones while you do it. Actually, I think we might have one already. Yes, we do. So we've got one from Richard Penn. So with increasing regulatory pressure even on PFAS materials, how do we see the potential impacts, if any, on lithium-ion battery manufacture and material choices?
Yeah, someone said to me once, and I continue to use this joke as he leaned over to me at a conference I think we were discussing cobalt and how that's become a conflict mineral, and he said, if they keep canceling elements, what are we going to make batteries out of? And I thought, so we don't like cobalt because it's difficult to get, and it has a lot of conflict regions to get it from. Graphite's very dirty process to make that. Lithium is very light. You need these very giant pools to get lithium and to refine it. So these other chemistries come up. Sodium ion then becomes attractive. But we're also looking at things like PFAS, like the viewer saying. NMP is another one. It's a solvent that we use to make the cathode slurries and that we co-cathode in. I think that we're going to continue to see regulations around these things, and there are definitely companies that are working on eliminating some of these things. We're working with some companies that are working on getting rid of NMP and going to friendlier solvents in the cathode. We're looking at companies as we get to the not just the next chemistries, but the next ways of processing. Just taking the solvent out of the formulations totally into dry coating. Lectures is a company in the UK called Anaphyte who's working on some dry coating technology, and they were just showing me how they're getting to really high coating speeds right now. I think they're up at 25 plus meters per minute. Those things are coming on, and so you start to I think we're going to have to start looking really closely at deploying those technologies so we can get away from some of these elements and materials that are going to be regulated.
Okay, we've got one from Denis Passarel from Ilika, who we name-checked earlier. Do you think that the UK and Europe should concentrate on LMR, lithium manganese rich, in the way GM and Ford have announced partnering with LG?
Yes, I think that all chemistries, as I think every chemistry has its application, and focus on it. I think companies are making their bets for whatever reasons that they are, it's hard to say. Jonathan asked me the question earlier. He's like, who will be the winner? And I avoided it by saying that every chemistry has its application, and I would still go with that. There's a techno-economic case that needs to be made. Do these scale? Can we reach economies of scale? Are they easily deployable? I think that there's a lot of boxes that need to be checked on that journey. But I'm excited for all the chemistries that are being worked on, because I think that we need a wide range of them.
Okay, we've got one from Angus Condy. He's used the chat. Naughty Angus, who should be in the Q&A. Is the UK not at a big disadvantage since we do not have the raw materials, so it would be difficult to be competitive?
I think we talked about that a little bit through this. It's one of the big challenges we have is in the raw materials. So I think that's where things like Altilium comes in, where we're doing recycled material and bringing that circularity, where companies that are working on high silicon chemistries come in to try to lessen graphite. If we look at even the current collectors, aluminum foil and copper, I know there's some entities in Europe and in the UK that are working on those things, and also in the US and Canada. It's going to take some time, and let's face it, it's going to be difficult to get to the price points that China has been able to get to. We haven't really even talked about labor. It's a disadvantage for sure in terms of where we are right now. Can we close some of that gap? Sure. Are we ever going to get it down to where China is? That seems unlikely. But are there places where you can deploy those things and technologies and applications where that are less cost sensitive that can be done? I think that's probably possible as well. So, we talk about winners and losers, but sometimes maybe it's about closing the gap enough.
Okay, I've got one from Walter Zhang that rather implies that you might end up being Prime Minister, but I'm not sure if that's going to happen or not. So the UK and Europe are currently highly dependent on China for cell supply. As battery cells are a critical and indispensable part of the EV and ESS value chain, does the UK government have any plans to build its own domestic cell manufacturing capacity? Rather than put you in Keir Starmer's shoes, do you think that the UK should have its own domestic cell manufacturing capacity, or is that something that's best left to the market?
I mean, the market will decide. So I figure that's maybe that's where it needs. Maybe that's how it needs to lead. When governments try to build things, sometimes it doesn't go as well as you want it to. So,
well done. I've got one from another familiar name, Graham Purdy. If you were building the UK's next gigafactory, which chemistry would you choose? So there, you've been Prime Minister. Now you get to be a titan of industry.
If I were, so it's an interesting one because S&P Global has said that they expect that from the mobility market by 2030, that 60% of that market will be LFP, and that in the stationary market, it will be 90% LFP. So from that perspective, I would say, well, it would be obvious you should build an LFP plant. But I think that if you're going to be in the UK and you look at the customer base that you're looking at there, and you look at the competition, we have a lot of, where we sit in Coventry right now, and there's the automotive heartland of the UK, and there's a lot of car companies around us right now that LFP might not be suited for. And I think those companies still want to make cars and they would like to electrify. You're talking about, McLaren and Bentley and Lotus and Rolls-Royce. That's more suited to a higher nickel chemistry. And if we're looking at things that could also satisfy things like defense applications, so MOD, maybe looking for things like that because they're looking for things that can be carried around, or things that can be flown. So you put them on drones. So you're looking for that higher energy density. You're looking at vests that soldiers wear, and all the they have these, I think it's called conformable wearable devices, one of those words. And it's a vest that has lots of batteries in it, and it powers all of their electronics. So they want that to be light, so that lends towards something that's higher energy density. They want it to be small as well. I don't know if I've avoided the questions enough here.
I think as Graham's answer asked the question, the answer is probably solid state from Graham's point of view. But let's not worry about that. So
that's a tough gigafactory.
Yeah, indeed. So I'm afraid I'm going to massacre your name now. So from Zhang Huang, how do you view the commercial prospects and scalability challenges of all solid state sodium batteries in the current energy storage market?
Sorry again.
So how do you view the commercial prospects and scalability challenges of all solid-state sodium batteries in the current energy storage market?
All solid. So the commercial is.
Yeah. So how do you view the commercial prospects?
And
scalability challenges?
Yeah, commercial prospects. If there's a customer, people will buy it. Scalability challenges. Sodium ion can be scaled pretty well. I'm not sure if they're asking with a solid state chemistry, or separately solid state.
I think with a solid state.
Okay, it's interesting because they have a low energy density chemistry with something that's paired for something that's high energy. But I think again, if there's a market for every cell, every application, every chemistries, or every form factor has got its application. I think what people need to understand, though, is that scaling and commercializing anything is very difficult. And we talked a lot about that today. And it takes a lot of money to be able to do that. So even even known chemistries that we have. You see some of the gigaplants that are starting right now. It's a huge, massive investment and they're commercializing known chemistry. So just commercializing something that's a high nickel chemistry with a graphite anode with some amount of silicon in it. It's a huge amount of time and a huge amount of money to be able to get to that commercialized phase. So, if we're talking about sodium ion solid state or sodium ion with solid state, you have your own technical challenges, but then being able to scale that takes a lot of time and a lot of money. So I think that's where where the commercial aspect is going to be coming in.
Okay, we've got another one from Richard Penn, which is, do you think the recycling of LFP chemistry batteries will become economically viable in the near term? And if so, what are the steps to that viability, with a side order of, will that be in the UK as well? Well, it's 2 question marks there, so he clearly has his doubts.
Yeah, it's a tough one. Recycling is an interesting one right now because we keep making the batteries last longer and longer and longer. So if they're going to last 15 years, we're going to wait for that massive material to come back to recycle in large quantity. It's something that we need to do, but as time goes on and we get more of those cells back and we can recycle them, they're going to become more of the value chain. Are we going to see 100% recycled material in cells? Probably not for a little while. But there are goals in the UK to have some amount of recycled material in cells, and I imagine that will keep that. And as we, like we said, there's more and more batteries being made and deployed into the world year over year. Eventually, these are going to be coming back to be recycled, and so we should see recycled content go up over time.
Okay, that's great. I think we've got through all of the questions pretty much, and we're pretty near the end as well. Just to say that the next of our webinars will be Unlocking Skills and Training for the Battery Sector with John T. Dealey-Williamson, who is head of our L&D department. That'll be next month. And again, we'll share the date and the details of how to get involved with that a bit closer to the time. And then just to point out that we've got a few speakers out and about. Richard himself will be at Fraunhofer on the 21st of October, talking all about UKBIC. Andrew Britton from our business development team will be at the IMEC conference just down the road at the British Motor Museum in Warwick, also on the 21st of October. The Advanced Engineering Show, which is the NEC, which is a bit further down the road, and Yaya Alvar from our BD team and John T. again will be speaking at that. And then finally, the Batteries event in Lyon, we actually have a stand there, so you can come and visit us and have a chat. And Richard will be there as well, in actual fact. And Yaya has a speaking slot as well. So on that note, I think it's probably time to end the webinar 1 minute early. So just in time to say thank you to everybody for taking part, and thank you for Richard for gamely answering everybody's questions.
Thank you.